Okay, there's really one topic we're talking about today. We're going to talk about graphing. So we're going to go in two different directions. First, I'm going to give us an equation, and we're going to draw the graph. Then I'm going to give us a graph, and we're going to write the equation. So everything, though, revolves around graphing today. Okay, here's the first idea. For any graph that we're doing today, we're graphing polynomials. We are going to start by finding the x-intercepts or the zeros. For every zero, you need to be able to determine what the behavior of that zero is. Here's how you're going to do that. For every zero, you're going to look at the power on that zero. If the power is even, the graph is going to bounce off of that value. On the other hand, if the power is odd, the graph is going to pass through that value. So if we're odd, we're going to pass through. If we're even, we're going to bounce off. Okay, the easiest way to see this is just to do some examples, so that's what we're going to start with. If we look at example number 1, it says find the zeros or x-intercepts for p of x, then use the powers to determine the behavior at the intercepts. Also sketch the graph. You should be able to determine the end behavior and relative max or min. Okay, a lot going on here. Here's how we're going to start. Zeros, remember, means that the output is 0. So the first thing that we're going to do is we're going to set the output equal to 0. Okay, do not do extra work. This is already factored for you. Don't multiply anything out. So what you're doing is you're setting each of those factors equal to 0. Okay, so that tells us that we have 3 zeros. At x equals -1, at x equals +1, and at x equals +3. So all I did was set the factors equal to 0, and I got 3 values. Okay, so the next thing we have to determine is the behavior at these zeros, or the behavior at these intercepts. Like we read above, that's based on the power for these zeros or these factors. So we have a power of 1, a power of 2, and another power of 1. All we care about, remember, is if that power is odd or even. For x equals -1, so that comes from this first factor, odd power means that the graph will cross. At x equals 1, that comes from the middle factor, has a power of 2. Even power means that the graph will bounce. And then at x equals 3, we have an odd power again, which means that our graph will cross. This is almost enough information to graph this polynomial. It's not quite, but it's almost enough. Questions so far? Okay, so here's what we're going to do then. Sketch yourself a coordinate plane, please. We're going to put our zeros in. So we have a point at x equals -1, a point at x equals 1, and a point at x equals 3. Now, we know at -1 we need to cross through, at 1 we need to bounce, and at 3 we need to cross. The last thing that we need to do is we need to determine our end behavior. Okay, so if we think back to what we did previously, there's a 1 out in front here. It's not written, but it's understood to be there. What does that 1 out in front tell us about the graph? Thinking back to end behavior. Not quite, but thank you.
It ends going up.
It ends going up. So what we care about is that 1 is positive. So what's going to happen is this graph will end up. And now we're going to follow our behavior. So at x equals 3, we said we're going to cross. So when we get to x equals 3, we have to cross. Then we're told at x equals 1, we need to bounce. So what that means is we have to come back up and hit x equals 1, but we're going to bounce. And then x equals -1, we're going to cross. So when we get to that x equals -1, it's going to cross up like this. Now, we need to do a mental check. Based on just looking at our graph, should the degree of our polynomial be even or odd? Looking at the graph. Even. How do we know? Starts and ends the same. Starts and ends the same. So we need to make sure, looking at our equation, that that makes sense. Is this even? Well, we have 1x, we have another 2 x's here, and we have another x. So that tells us we have x, 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 x. If we were to multiply it out, we would have x to the 4th, which is in fact even. So always do that mental check and say, does this make sense with what I have? Now, one thing I will tell you is we don't know how far down these go. Okay, so we don't know how far down those peaks are. We're just using what we're estimating. That is the expectation. Drew?
How do you know, like the first one, like, is like the farthest, yeah,
That one? We look at the number out in front. So because it's positive, we're going to end up. That's where I started.
So the first term, you know, if it's negative, you start down, if it's positive, you start up.
Okay. Does this have a relative maximum? I'm not asking you to find it. I just want you to know, yes or no, does it have a relative maximum? Yeah, right here. Right there. So yes, it does have a relative maximum right here. Does it have an absolute maximum? Does it have an absolute highest point on the graph? No. No, it goes up forever. Does it have a relative minimum? Yes, it's going to have 2 here and here. It would also have an absolute minimum. We don't know, though, what it would be because we don't have enough information. That's the basic idea. In the example in B, we're going to add on because it's not factored. So we're going to need to factor in B. So right now we're going to do B, and then you all will do C. So starting with B, we set our output equal to 0. On the left side, I have a GCF, and that GCF is a negative x. So I can take a negative x out of everything, which gives me x squared, subtract 4x, add 4. So I chose to take out a negative x because the first term is negative. And now I can factor what's left. So I'm looking for 2 numbers that multiply to 4 and add to negative 4. What are those 2 numbers? Multiply to 4, add to negative 4?
-2 and -2.
Very good. -2 and -2. So we have x minus 2, x minus 2. Now, this is not really the best way to write it because there are 2 x minus 2's. So we do need to somehow convey that. The way we do that is we write this as x minus 2 squared. And now we are at where we started in part A. We have a polynomial that's factored. So we need to find our zeros from here. We set negative x equal to 0, and we set x minus 2 equal to 0, which tells us that our zeros are at x equals 0 and x equals 2. Now if we figure out the behavior, that x equals 0, that factor is x to the first. That number is odd. So that tells us that x equals 0, we are going to cross. The x equals 2, though, is even. So for that one, we're going to bounce. At this point, I would draw a graph or a coordinate plane with those 2 zeros labeled. We're not ready to finish the graph yet, but that's where I would go from here. So at x equals 0, there's a point, and at x equals 2, there's a point. Okay, so then if you remember from here, we're going to go off of the end behavior. Our lead number is negative, which means our graph is going to end down. And now we need to fill in the rest. At x equals 2, we need to bounce. So at x equals 2, we're going to bounce. And then at x equals 0, we cross. So when we get back to x equals 0, we're going to cross and go up. Looking at the picture, is this even or odd? Even or odd? Odd. Starts and ends differently. Please tell me that we all know this, not just Maria, because Maria's the one that has answered every single time. Yeah, even or odd, which we need to say, yeah, that makes sense. X to the third is odd. Okay, questions for me before you all try the last one. Okay, in C, I'm going to get you started. Make your output 0. How would I go about factoring this one, Audrey? Yep, split it into 2. So this is where I'm going to leave you. Take 2 or 3 minutes and complete this entire problem. Find the zeros, find their behavior, and draw a graph. Okay, this is what I got. You should have factored as much as possible. So there are no zeros that bounce. All of them should cross. Because this x squared minus 1 factors again. This does not count as having a multiplicity of 2. So all of them cross. And again, you need to make sure that your graph ends up being odd. So I saw quite a few of you when I was walking around had a 0 that bounced. And so your graph started up and it ended up. That would be even. That's not an odd function. So that should tell you that something went wrong. One note I want to give us real quick is if I were to ask you for the x-intercepts, so if you can write this down, please. We've talked about this before, but I just want to remind us. If I ask you for an x-intercept, that's the same as a 0, but it has to be written as a point. So if I were to ask you what are the x-intercepts here, you would say 1, 0, negative 1, 0, and 4, 0. So just remember, intercepts have to be written as points. Real quick, before we take a break, is there a relative maximum? Relative maximum. Yes. So that should be right here. Relative minimum. Is there a relative minimum? Yeah, right here. Absolute maximum, absolute minimum? No. Graph forever goes up, forever goes down. Okay, so second half of the notes. We're going to do some more graphing. There's this idea at the top. A polynomial of degree n has at most n zeros. That's basically what you need to know. So if something is x to the third, it has at most 3 zeros. That's pretty much what you need to know. So, example 2. We are again finding the zeros, their behavior, and graphing. 2a you can do. So I want you to take 2 minutes and do 2a, please. It's exactly the same as what we've been doing. So find the zeros, find their behavior, graph the function, please. Here we go. So you should have found 2 zeros at negative 4 and 1. The one at negative 4 should cross because we have an odd power. The one at 1 should bounce because we have an even power. Now, this is just a fun fact for you. The fact that this is a third power is something special. Do you all know what the graph of y equals x to the third looks like? What the shape is? Some yes, some no. It looks a little bit like a snake. So if something has a third power at that 0, it crosses snake-like. Now, I don't care about that. All I care is that you know that it crosses. But that's why on my graph you see a little bit of that curve. It's because of third power. Third power is snake-like. Okay. Questions before we do the last one? Okay. So last one is B. We're going to start by finding the zeros like we have with every other problem. So we have x add 4 squared, and then we have x squared minus 9 squared. Okay, this one's different. This one's different than the other ones we've done because this x squared minus 9 factors. X squared minus 9 is x minus 3, x plus 3. But then we have this second power being applied to all of x squared minus 9. So what that means is that second power goes to both of these. So if we want to rewrite our polynomial, we get x add 4 squared, x subtract 3 squared, x plus 3 squared. So then our zeros are at -4, 3, and -3. Behavior-wise, we have even power, even power, even power. All of them are going to bounce. All of them are going to bounce. So that's what we're going to graph. We have -3 and -4, so -3, -4, and then +3. Okay, we have a 1 out in front. That's positive, which tells us our graph is going to end up. So then we're going to bounce. We're going to bounce again. We're going to bounce again. Whoa, that did not look nice. Okay, so bounce, bounce, bounce. Okay. Picture, is this even or odd? Even, starts and ends the same. So the picture shows us an even function, or a function with an even degree, because we start and end the same. What is the degree on our polynomial? If we were to multiply everything out, what's the highest power we would get? We think it's 4, it's not 4, it's a little bit bigger than 4. 6. So we have x squared, x squared, x squared. So our degree here would be x to the 6th, which is in fact even. Does this graph have an absolute maximum? Does it have an absolute maximum? No. Does it have an absolute minimum? If I were to ask you what is the value of the absolute minimum, what would you say? Audrey? It would be 0. So if we look at all these points, the y value at all 3 of them is 0. Okay. Any questions on the graphing before we do one last example that's working backwards? Okay. Last thing we have to be able to do is work the other direction. Given a picture, we have to be able to write the equation. Here's the general idea. First thing we're going to consider is we're going to consider the end behavior. So one thing we know, our graph ends up, which means our lead coefficient is a positive number of some type. What do we know about our degree? Even. Starts and ends the same, so we're going to have an even degree. Okay, so here's where we can start then. P of x is equal to, our beginning number has to be positive, but we don't know what it is, so I'm going to put positive a. A is just some number. We can't deal with the degree yet, but we're going to check that at the end. Now we have to look at the zeros. So we're going to notice we have 3 zeros. We have a 0 at -2, at -1, and at 1. So our zeros are at -2, -1, and 1. We need to turn those into factors, though. So if I take x equals negative 2 and I move 2 over to the other side, I get x plus 2 is equal to 0, which tells me that my factor is x plus 2. If I move 1 over, I get x plus 1 equals 0. So that gives me a factor of x plus 1. And then if I move the 1 over, I get x minus 1 equals 0, which gives me a factor of x minus 1. Okay, that's not it though. We have to make sure that our behavior is appropriate, that the behavior of the intercepts matches our equation. Okay, so what we notice is for that negative 2 on the graph, bless you, we need to bounce. If a 0 or an intercept bounces, what does that tell us? Yes, that it's an even power. So on that x plus 2, we need an even power. I'm going to go with squared, but you could put the 4th power, the 6th power. All I care about is that it's an even number. At negative 1 we cross, and at 1 we cross. So those are going to be odd powers. One is an odd power, so I'm just going to use the first power. Now, you don't need to write 1. It's understood to be there, but any odd power would work. So if you want to do 3, 5, whatever you want, that will work. In your homework, this is the answer that I'm looking for. One thing I forgot to say, make sure you end up with an even degree like we said in the beginning. What is the degree of our equation that we've written? 4. Yeah, x squared, x to the first, x to the first. So we're going to end up with x to the 4th, which is in fact even. Last thing I want to talk about real quick. If I asked you to find this number out in front, how would we do that? If I asked us to find that number out in front, that a, how would we go about doing that? Any ideas? Okay. Way you can do that is pick another point on the graph we haven't looked at yet. We've already looked at all 3 of the zeros, so we can't touch those. What is another really convenient point that we have not considered?
Negative 4.
Yeah, the y-intercept, this point right here. So that is the point 0, negative 4. Write this down with me, please. We're going to find a. So we're going to use our equation, and we're going to plug in 0 for x and negative 4 for y. So we get negative 4 is equal to positive a times 0 plus 2 squared, 0 plus 1 to the first, and 0 minus 1 to the first. So we get negative 4 is equal to a. 2 squared is 4 times 1 times negative 1. So we get then negative 4 is equal to a times negative 4. So we end up with an a value of 1, and that's positive, which we knew it was going to be. So then what we really know is that our equation is p of x is equal to positive 1 times x plus 2 squared, x plus 1, x minus 1. Now, if the number out in front is a 1, you don't need to write it. It's understood to be there. But if I asked you to find a, that's how you would do it. Pick another point that's on the graph that's convenient. That being said, in your homework, when I say write an equation based off of the graph, this is what I'm looking for. I don't expect you to find a, but I do expect in your equation to have an a and you to say if it's positive or negative.